Hello and welcome back on day 5 of the HMN Network Wheel Reinvention Jam. It's actually day 6 of the jam, but I couldn't make much progress yesterday, so let's say it's day 5 for me. So this morning I programmed a very simple automatic layout system for the application's UI. It's not a fully fledged system, it's not very capable for now, but admittedly automatic layout for UI is not a problem that I spend much time thinking through, so what could we expect? But I think it's enough for now. It allows us dropping some UI widgets into the application without thinking too much about rectangles and layouts, so it will do. So let's see how it works. So I took inspiration from two different layout systems. One is Micro UI, which is a very simple and self-contained, very well designed library for UI that you can find here on GitHub. And the other one is that article about RectCut for dead simple UI layouts. So my system is a bit of a mix of both. So here in my api.h file, I added some more functions for the UI. Here are the simplified widgets, and here are the basic functions for the UI. You can set rows and columns and create nested groups. So I will try to explain how the UI works using that whiteboard application that I just downloaded, so I don't know very much about it, but bear with me. If I can see my mouse cursor somewhere. Okay, here we are. So let's say we have a rectangle in which we want to do some layout. And you will soon see that my graphics design skills are not very good. Okay, so here we have what we will call the free space. So the layout system works with columns and lines. So let's say I use the set columns function first. My UI layout system will then cut a rectangle from the free space, and that rectangle will become what I call the workspace. Then each time my UI requests a new rectangle for a widget, the layout system will cut from the workspace beginning on the top. So basically I can make some cells into that column. And when I overflow the maximum number of cells that I specified for my column, the system will cut another column from the free space. And this new column will become the workspace. And I can continue to cut cells from that column. Now let's say I call set rows to make some rows. The system will cut from a row from the free space. So that first row will become the workspace, and the free space has been cut. And now if I request rectangles for my UI widgets, the system will start cutting rectangles from the workspace beginning on the left. So that's very basic and simple. It's basically a rect cut under the hood, but we don't have to explicitly manage rectangles or pass layout objects to the UI widgets. Another important thing I can do is create groups, so it allows me to create nested layouts. So let me clean up a little bit. Okay, now let's see, I'm in my column here, and I push some group. So the layout system will cut cell from my workspace as usual, but that cell will become a layout. So it means this cell will become free space, and I can start cutting, for example, columns from that free space, and cut cells from that new column. And when I end my group, it will pop the layout, and we will find ourselves in the situation where we have the workspace here and the free space here. So it allows me doing nested layouts inside cells. So that's a very simple and basic system, but it allows us doing basic things. We can't do really fancy UIs, but since it's for simple prototyping application, I think it will be enough. So let's see how it all works. I have here my layout structure, which contains a bunch of rectangles for the frame we are in, the free space remaining on the current workspace. We have a number of other values here, the flags that are passed to our set rows and set columns functions, some padding to space the widgets, the number of cells in my current row or column, the dimension of the cells, the direction in which we are doing the layout, and the current cell. In my context structure here, I just wrap the UI context from my application layer and some scratch memory arena and a layout stack. So the layout stack is very simple. It works from a free list and a list for the stack. So pushing a layout is just getting a layout from the free list and pushing it on the layout stack list, and popping a layout is just popping the layout from the layout stack and pushing it back into the free list. Now here I have my initialization function where I pass the layer, the platform layer's UI context and the scratch memory. I initialize the layout stack and I push a first row. Then the function that powers it all under the hood is that rect cut function. It's just taking a cutting direction, which can be from the top or from the left, the size we want to cut, and the rectangle we want to cut. And it returns the rectangle that we just cut, and it also modifies the base rectangle that we passed. Now I have a single function for setting rows or columns, and it's just cutting a new row or a new column from the free space. and setting the cell's dimension. So we can either pass a null pointer here in cell dimension, so the system will automatically compute the cell dimension by dividing the whole dimension of the row or column by the number of cells. Or we can pass a pointer to a single U32 value and a flag that tells the system to affect that value to all cells. Or we can explicitly pass a cell dimensions array. So we are setting that up here, and then we set the cell count and reset the cell index to 0. One important detail is that if we were in a cell or in a row or in a column where we haven't pushed any widget yet, we just roll back the free space, that is, we undo the last cut. So basically we can call set rows or set columns multiple times, and if we don't do anything between the calls, the last call will be the one that's taken into account. That allows us setting some default rows, but still letting the user override this without wasting space. So set rows and set columns are just wrappers that get the implicit context and the top layout, and that use the set row or column function, passing them the right arguments. And then I have my actual function that returns the next rectangle from the layout system. So depending on the direction of the layout, it will cut from the top or from the left of the workspace. And here we are just handling the case where we are overflowing the current row or column, and we are asking to cut another row or column and resetting the cell index. And then we just cut from the workspace and increment the cell index here. That gContextNextRect function, it just requests a rectangle from the layout, and it applies some padding, and it returns a slightly smaller rectangle. So that function is used by the widgets to get their rectangle. And that one is just a wrapper that can be directly called by the user, so it's just requesting the implicit context here and passing it to gContextNextRect. Now groups are very simple. We just request the nextrect from the system, and then we push a layout using that rect as a frame, and we push a default row in that layout. And end group is just popping the top layout. So now we are in a good position to start having some simplified widgets. And they are just little wrappers around my platform layers widgets. So they are getting the implicit context, and they are getting the next rect from the layout system, and they are calling my platform layers UI functions here. GSlider does a little bit more work because we are mapping values between low and high into a 0 to 1 range and mapping them back, but nothing very fancy. And checkbox is also a simple wrapper. Now we can have a look at my DSP.c. Here I have my UI procedure, which is already much simpler than it was because I'm just using the widgets without thinking about rectangles or layout, and just dropping some simplified widgets into the application. So let's see what it does in the application. Here we are. Now when I don't deal with any layout stuff, the widgets will just take up all the width of my view, and they will stack vertically. But let's say I want some fancier layout. So maybe I want to have my labels next to my sliders. So I would want to organize them in rows of 2 cells. So I will use set rows here. I will set the row height to 80 pixels, and I want 2 cells, and I will let the system compute the width of the cells. So let's see here, if I hit the build shortcut. So my UI is updated, and we can see that it's laid out in more nice way. Okay, so here it is for the layout. I think it will be enough for now. It's admittedly simple. We can't do very fancy stuff, but we can drop layouts and have it works in a nicer way than the previous system. So now I think it's time to add some more widgets, more specific to that application. Oh, there's a nice cat here. Can you see? Hey, hey buddy, do you want to say hi? No? You want to play with that rock? Let's play with that rock. Okay. So, yeah, we may want to add some widgets more specific to the applications, like dials and curves that will allow us to make nice envelopes for the DSP helpers. So that's what I'm going to do next. Okay, so now we have some new UI widgets here, and we have a curve editor, which will be useful to add some envelopes or tempo curves. So we use that structure, curve editor, and that's a structure that we get from the application we call getCurveEditor, and it will return us a pointer to a curve editor structure that's allocated from the persistent memory. And then we have these two functions. We have one function to make the UI for the editor, and we have a function to query the value of the curve for some value of x. So now if I open my dsp.h, it's here, I asked for a curve editor here, and in my UI procedure, if I have already initialized the editor pointer, I do the curve editor UI. So let me show you how it looks. So we have this curve editor here, and it's based on Bezier curves. So you have points, endpoints, and control points. If I click anywhere I add a point, it will break the curve at that point and try to do a smooth transition. So I can add point like this. And if I click a point while holding the Alt key, I delete the point. I can also make non-continuous curves. You see that here I have a point selected, it is shown in red, and if I hit Control C, it toggles the continuity at that point. And if I click Control C again, it will make the curve continuous back. So we can have a nice envelope here. For example, let's see. Okay, let me delete that point and make some kind of nice envelope. And here I used the curve to drive the amplitude of my output signal. So how I do this in my DSP procedure, I added these variables to my parameter structure. Envelope trigger, it's what's set to true when I click the button. Envelope run is just to know if I'm running the envelope, and envelope time is the time that will get incremented if we are running. And now here, if I have triggered the envelope, I set the envelope time to 0, I set running to true, and I flip back envelope trigger. If we are running, I sample the curve at the value of envelope. So I sample it at envelope time over 2. That means our envelope will last 2 seconds. And then I see my girlfriend in the background. Mais c'est pas grave parce que ça a bugué. How it works is that I've added some members here in my parameter structure. Envelope trigger is used to trigger the envelope. Envelope run tells us if we are playing the envelope, and envelope time is the time during which we are running. And here, if I have triggered the envelope, I set the time to 0, I set running to true, and I flip back envelope trigger to false. If we are running, I sample the curve at time over 2. That means our envelope will last 2 seconds. And I advance the time, and if the time is more than 2, I say that we are stopped. And then, yes, I multiply the sample by the value of the envelope. And in my GUI procedure, I just call the envelope editor. So pretty simple from the usage code point of view. Now let's see the implementation. So our curve editor is defined here, and what's important is that it has a list of elements which are of type G-curve editor elements. And for now, I just implemented Bezier curve elements, and we can implement linear curves later. but those Bezier curve elements have 4 control points and continuity condition for the start and end points. Then I have some functions that deal with computing Bezier coefficients from control points, sampling Bezier curves at x and y, solving the S parameter of the Bezier curve for some value of x. That one is just Newton-Raphson solver with a fallback on the second method. So this function gives us some value of s for some value of x, and from the s we can then sample the curve y. I have some other helper function that splits Bezier curves. I have function to insert points into the editor, so that's just splitting the curve at one point and inserting elements in the editor. Same kind of thing for the deletion of points and the toggling of continuity. Then that function is used to get a curve editor from the persistent memory and initializing it to some sensible default values. And then here is my curve editor UI function. I'm just computing dimensions of the plot, and here I deal with clicking on control points. So if I have clicked on inside the plot, I find the element which has been clicked, and either we clicked onto a control point, in which case either we are dragging that point or we are deleting that point, and if I clicked somewhere else, we are just creating some new points here. And here is dealing with the toggling of continuity. And if we are dragging a point, I'm just updating the control point, and I make sure that if I'm dragging an endpoint, I also move the control point of the previous element of the next element accordingly to keep a smooth transition at the point I'm dragging. Here is where I enforce continuity at the bounds if the point that I'm dragging is the first or the last point of an element. And I also have to ensure that my Bezier curves indeed represent a function, because the Bezier curve could curve around and have multiple values of y for one value of x, which would be a bad situation for us. Okay, and now I'm just rendering all my elements, and I'm just taking the control points and using the graphics layer of my platform layer to draw the curves. Here I have my my curve read function that samples some value of y corresponding to some value of x. I'm finding the element in which x lies, and I'm solving the Bezier curve for x, and then I'm sampling the Bezier curve y for that value of s. So that's it for the basic curve. So we have some nice way of doing envelopes, and I have also added an easier widget, which is a circular dial. So let me see here. We have a dial here. So let me show you how it looks here, which I can adjust to some value. So a simple dial, and the code for the dial is here. It's essentially the same code as the slider, except that I'm drawing some arcs, and so I'm mapping the value of the slider to some range of angles. So nothing too complicated, but that will be, I think, useful because linear sliders tend to take up a lot of real estate on the screen, and sometimes it's nice to have some nicely grouped dials. So here it is. We have added some more specific UI for audio application. Okay, so let's stop here for today. Tomorrow, I think I will try, if I have some time, I will try to add some helpers for the GUI processing. So I could add some building blocks for envelopes, and I could add some building blocks for smoothing values, stuff like that. I don't know if I will have a lot of time tomorrow, but we will see, and it will be already the end of the jam. Time flies. So see you tomorrow.